And our last valve that we have is basically, we started off as a manual choke. And basically what it does is again, extremely simple. It's just kind of like a valve. So basically if you've got a choke that you would have in here, a manual choke, it's just basically a matter of opening and closing a valve. Well, basically with this one here, you would have this needle valve hypothetically 2 turns open, and by adjusting this one open and closed, it's basically like opening and closing that manual valve. So basically the more you open it, the higher the flow goes through it. The more you close it, of course, the less flow that can go through it. And again, with our valve, with this type of technology, what we find is that, again, in abrasive conditions, you're dealing with a lot of pressure drop. Our valve can stand up exceptionally well in those kind of applications, and typically do it at a very competitive cost. And we're even to the point now where we're looking at setting our valve up as a automatic choke, where you can have a device on here that has a rotary, and basically just by sending a signal to it, you can tell it to open and close, so that you could actually have this valve set up as a fully automatic choke, receiving a signal from a computer or from your PLC that would send a signal to it to either open and close depending on what's happening with that application. So again, again, just to kind of recap, basically it's just initially set up as a manual choke, where by adjusting your downstream needle valve, what it does is by adjusting that, either open or closed, will simply increase or decrease your flow through it. And again, because of our valve design, we stand up exceptionally well in very high differential and erosive applications.